to doctors and members of the floor. I'm Faridah Aminullah, and I will present my topic today entitled Green Synthesized Silver Nanoparticles, a future intervention to minimize antibiotic resistance. So because actually I created this slide for 12 minutes, but I think we just have 8 minutes, so some part maybe I will just skip. So for the introduction, what is antibiotic resistance? Antibiotic resistance, or sometimes referred or termed as antibacterial resistance, is actually a condition where, as this picture here depicted, this bacteria actually develop or can defeat the treatment or the agent that was designed to kill them, right? Or in other simpler words, is when the bacteria become susceptible to the antibacterial. And how this happens is actually because these bacteria have the ability to undergo genetic changes over time. These genetic changes actually refer to the mechanism of resistance that these bacteria can undergo, right? And this antibiotic or antibacterial resistance is actually one of the problem in healthcare system due to the fact that this map is actually represent a distribution of the resistance in bacteria globally. So we can see that a lot of bacteria become resistant over time. And this table is actually taken from an annual report from CDC, which is the Center for Disease Prevention and Control, for the year 2019, where we can see that each time antibiotic is released or used, there will be resistant germ that will identify against that that antibiotic. So silver nanoparticles, on the other hand, has been long incorporated in medical devices as antibacterial agent, right? There are actually a website known as NanoState, where you can see that in that website, silver nanoparticles has the highest number of elements that has been incorporated in the majority of the medical devices. So, all right. So recent findings suggested that silver nanoparticles that was synthesized by green methods possess this broad spectrum antibacterial. This is due to the fact that these silver nanoparticles act in a very broad way against bacteria. If you can see here, this is actually a proposed mechanism against how silver nanoparticles actually acted against bacteria. But like Dr. Nick said, it's actually just a proposed mechanism and nothing is certain yet because the mechanism is still under investigation. So, sorry, it's too fast. So the aim of my current objective is that we would like to study the antibacterial activity of silver nanoparticles that was synthesized using this extract of odorata or damkasol against several bacteria, which is listed here. And before we proceed with the antibacterial study, we did characterization and we conclude that we are managed to get spherical morphology of the silver nanoparticles and using this extract. So we started with this diffusion assay. If you can see here, I'm gonna slow down a bit. So if you can see here, we use 3 different amounts of silver nanoparticles. The reason here is that we would like to, we're interested, right, to look at the relation between different amounts of silver nanoparticles against the inhibition zone, right? So if you can see here, there are a pattern where we can observe that increased amount of silver nanoparticles will result in greater inhibition zone. This is actually observed throughout all the 4 organisms. And we proceed with time-kill assay. The reason why, because actually through time-kill assay, we can observe at which at which hour or at which period time these silver nanoparticles can actually inhibit the bacteria, right? But before we proceed with this time-kill assay, we determine its MIC value. MIC value is actually a minimum inhibitory concentration, or in other words, it's the lowest concentration of silver nanoparticle needed to inhibit the bacteria. So you can see here the aureus strain have 125 microgram per mil, whereas the epidermidis and aeruginosa is 63 microgram per mil each. Alright, so these three graph is actually gram-positive and this is gram-negative. Overall, in conclusion, you can say that silver nanoparticles are able to inhibit the bacterial growth. But what is interesting in here is that, if you can see here, for the gram-negative bacteria, within the 4th hour, there is a maximum inhibition. Alright, this observation might be due to the fact that gram-negative bacteria actually has thinner cell wall compared to the gram-positive bacteria. So that is the reason why the interaction or the action of the silver nanoparticles is more prominent against the gram-negative bacteria compared to the gram-positive bacteria. And as a summary, green methods is able to synthesize or to reduce the silver nanoparticles, and these silver nanoparticles that were synthesized using these green methods possess promising antibacterial activity. Okay, then I would like to acknowledge interdisciplinary research and my supervisor, Dr. Khairunadwa, also my co-supervisor, Dr. Thank you.